All right, what are some properties of logarithms? So first we'll start out with the change of base formula, also known as the change of base ratio. If it says write the logarithm as a ratio, it's talking about this. We have kind of already talked about this together, but here's a video or a little formal lesson for it. This logarithm has no base showing on it. So what is the base?
0.
It is base 10. When the base is not clearly seen, then you know it's base 10. Some of you guys can tell me the answer to this right away. It is 3. Okay? Take your calculator right now and try it. Log of 1,000 equals. You should get 3.
How about without it?
The next one, the ln, natural log, means log base e of 1,000. Now this one's not as pretty. So plug in natural log of 1,000. What do you get? Tell me, because I don't have it in front of me. 6.907 something.
Is there a way to do this?
Okay. 3 decimal places will suffice. And if anything, in anything, if you're not sure what to round it to, just round to 3 decimal places. You'll always be good with that. And in fact, we shouldn't say equals. We should say approximate because I did have to round it. I'm not going to write that big old number. Okay, now for the next one. Sorry, I gotta let's do this. Okay, it has a base 3. Now, there's a lot of calculators, except for scientific Casios. I don't know about graphing Casios. I haven't played with those that much. Don't have the option to change the base. If you have a Casio, a scientific Casio, I know it has a button that looks like this. Log with the box right there and a box right there. It gives you the option to change the base. You press that button, you just have to plug this stuff in. Okay? But you also have to know the change of base ratio, even if you have that button, you still have to know what this also equals. This also equals the common log of 531,441 divided by the common log of 3. Punch in your calculators, see what you get. Now you can use the common log for it, or you can use the natural log. Doesn't matter which one you use, you get the same result both ways.
Is it log and then 3 or log subscript?
Now, I remember, no, this is log base 10 of 3, and this is just natural log of 3. I remember that the 531,000 number goes on top because here he's the bigger number, he's kind of already on top of 3, and that's just how I remember it in my head so I don't make a mistake. Get 12. Now, I made sure it was pretty, just because I think it's more fun when we get pretty answers. Now, there's 2 more slides here after this one to help us with practicing these properties. These are the most basic that they're going to get, and then I'm going to show you guys how to use them. Okay, so for this first one, because there's multiplication inside the logarithm, we're going to expand it, split it up, using addition. So it's log base A of u plus log base A of v. The next one has division inside the logarithm. Can you guys guess what's going to happen with this one? Subtract. So log base A of u subtract log base A of v. Now I'm putting parentheses around what's inside the logarithms just because I liked that when I was first using it. I don't know if you guys will like it, but I like to know what's inside of my log. It kind of helps me to not make mistakes. If things are multiplying together or dividing without parentheses and they're right next to a logarithm like this, then you're supposed to know that these are both inside the logarithm. But if there's a plus sign here, then you have to have parentheses to make sure you say that they're inside the logarithm. It's kind of complicated, so what I just do is every time something's right next to the log, I just put parentheses around and say, okay, that's inside the logarithm. This next one right here is my favorite. This one's my favorite. Okay, what you do with this one is you take this n. Whenever you have an exponent inside a logarithm, you could take them out and drop them like as if you were hot. So it actually equals this, n times log base A of u.
Why'd you do it in a different
For the first example, we're going to expand the natural log of 6. How do we expand that? Well, there's nothing multiplying to each other that we can see to get 6. So, can we split apart 6? Yes, you can. Natural log of 2 times 3. 2 times 3 would give me 6. So if it's multiplication, how would I write this in expanded form? With subtraction, addition, is there something I have to multiply? Yeah, it'd be natural log of 2 plus natural log of 3. The next one's a little more clear, just because you can see the factors and see how to split it up really easily. So we write this as log base 4 of x to the third plus log base 4 of y, because the x to the third and the y were multiplying to each other. Now there's one more thing I can do here, my favorite property. What is that one? Yeah, we can drop that 3 to say 3 times log base 4 of x plus log base 4 of y. Now, it's kind of, I don't know, it makes it a little, see, look at this right here. The property, the last property that we use is kind of obvious if you think of this right here like this. Log base 4 of x times x times x. Because we have this multiplication inside of this log, what can we do with those? We can split it apart and add them together, right? Split them apart and add them together. So what would we have? We would have 3 log base 4s of x plus log base 4 of x plus log base 4 of x. So we have 3 of these. Isn't that the same thing as 3 times log base 4 of x? Yes, it's way easier to just remember the property than to expand everything, then simplify it. Okay, last one. Now things are getting to be a little more hairy. Okay. Now, I had to remind you guys, when you guys have a radical like this, and there's no index number, then you know the index number is 2. And when you're working with logarithms, it's easier to work with rational exponents instead of radicals. So we're going to put parentheses around what's inside the radical right here and raise it to the 1/2 power, which is the same as a square root. I know, there's a lot of notation here you guys got to get used to. Now, we have all this stuff inside of this logarithm. How can I expand this? How can I split it apart? There's no multiplication in there. There's division. We do the subtraction one. So we're going to have natural log of 3x minus 5 raised to the 1/2 subtract natural log of 7. Is there anything else I can do before I box my answer? Yes, this 1/2 can get dropped right here. So we're going to put 1/2 times the natural log of 3x minus 5. Put parentheses around it. You have to have it because it has some subtraction right there. Minus natural log of 7. And that's your answer for that one. This is expanding. Now let's take a look at condensing. Only got 2 of these because they look gnarly. Let me give you guys a minute to copy them down. To condense this, and what you're trying to do, your goal when you're condensing is you're trying to have one logarithm. But now we have 2 right here, 2 and they're separated. I don't want that. I want one logarithm when I'm done. Okay, so first thing we got to do is get rid of the things that are multiplying to the log so that we can actually use the other property to condense it. Okay, so how do I get rid of those things that are multiplying to the logs? Yeah, those are now exponents. So I have log base 10 of x raised to the 1/2 power plus, and I'm going to move this 3 up there, so it's going to be log base 10 of x plus 1 raised to the 3rd power. Now, because both these logarithms have the same base, and it says plus right there, I can write the logarithm once, log base 10, and say x to the 1/2 times, x plus 1. And I'm going to put parentheses around the whole thing. Oh, where's my 3? To the third power. Put parentheses around it like that. Now, that's correct. But whenever you have a rational exponent and you're condensing it, I want you to write it not with a rational exponent, but with a radical. So how would I rewrite this? I would write everything the same except when I get to the x, I just say square root of x instead of 1/2. Because the square root has an index number of 2. And that's times, I guess I don't need that dot anymore, x plus 1 raised to the third. Let's put brackets around it. Brackets are the same as parentheses, they're just bigger. Alright, so that's that. Now for the next one. There's 2 ways to do this. The way I'm going to choose to do it is I'm going to condense what's inside here first, and then I'm going to worry about this 1/3. So what's inside right here right now? How can we condense that? Do they have the same base?
Yes.
Yeah, they do. So let's see, 1/3, and then we're going to write stuff right here. We have log base 2. Now, because it says plus, what am I doing with the x and the x plus 1? You're multiplying. So inside this log, I'm going to go x times x plus 1. Can I simplify that right there? Yeah, you can write x squared plus x. So it says 1/3 times log base 2 of x squared plus x. That looks nicer. Now what do I do with that 1/3? Yeah, he's now an exponent. So we're going to write log base 2 x squared plus x raised to the 1/3. We have a rational exponent. What can we do with that? Yep, so now it says log base 2. It's actually called the cubed root, or you could say a third root. And that's that. And if you want to, you can put parentheses around it like that. You don't have to have those, though. This is too long.